Hey guys, sorry I wasn't able to be in class with you today, but we are going to finish our discussion today of rational expressions. We started this last class period, and this is day 2 of the same types of information, and we're going to do several examples as always. But to start with, just as a reminder, last time we looked at simplifying rational expressions, including multiplying and dividing, and we also found that all the same processes that we were using to do that were the same as they were when we used just numbers. And so when we were using variables, we were doing the same way as when we were just using or without variables earlier. And the same thing is going to be true as we add and subtract our fractions in rational expression form as well. So we're going to jump right in. Just as a real quick reminder, because we're going to need it, we're going to talk about LCDs. So an LCD is a least common denominator. So if we have these two expressions, I have 3 over x plus 10, and I have 2 over x minus 10. Our least common denominator is going to be the multiplication of the denominators, as long as they don't have anything in common. And in fact, these do not have anything in common, and many of the ones that we're working with are going to have that feature. So if you were doing the least common denominator here, you would be multiplying the x plus 10 times the x minus 10, and that would be our LCD. And you can leave it in factored form. There's no reason to multiply that out. So using that information, we need that in order to be able to add and subtract, because as you know, we cannot add and subtract fractions unless they have the same denominator, right? So like if I had 1/2 plus 1/4, this isn't 2/6, right? I have to have the same denominator in order to add them together. And so I did things like, in this case, I multiplied the first one by 2 over 2, which gave me 2 over 4 plus my 1 over 4. And now that I have 2/4 of a pi and 1/4 of the pi, I have a full 3/4 of a pi, and I'm able to combine them. So thinking along those lines, we're going to do the same thing with expressions now. So here's a few of the first ones are actually going to have the same denominator, which is just kind of, getting us ready for the other ones that don't, of course. So these two have the same denominator. And as we know from working with just numerical values, same denominator means I then add the numerators together. You don't necessarily have to show this step, but I just want to remind you. So this would end up giving me 14 over 5x. The next one has as the denominator y minus 5. So in the numerator, we'll simply subtract, because this is a subtraction problem, the first numerator minus the second numerator, so I have y minus 3. And in neither of these, example 2 or example 3, are there anything that you can actually simplify, right? There's no factors they have in common. Like, let's look at the 14 and the 5. Those are relatively prime to one another. There's no number that divides both of them except for 1. And of course, there's no x on top to reduce with the x on bottom. In the second one, while there, yes, is a y on top and a y on bottom, there's no factors that are in common, right? Those are just terms that are in common. We need a whole factor, like we would need, if you kind of think about it, the whole thing inside of a parentheses to be identical, and it simply isn't. So let's try a couple more. This one, again, same denominator. So I have the denominator of 2x. And then in my numerator, I have 9x minus 3y. And then there's a subtraction sign here, so I want to be careful that I subtract each part of this, right? Whoops, that doesn't look quite right. Let me try it again. Each part of this. So I want to subtract the x, so that's minus an x. And then I want to subtract the negative 10y, so that's adding 10y, right? I need to subtract both pieces, and then I can combine like terms. So this 9x and this x make 8x. And then the 3y, negative 3y, and the 10y make a positive 7y. And of course, my denominator stays the same as 2x. And looking at the denominator in particular, it's a 2, right? Well, 2 divides 8, but 2 doesn't divide 7, so I can't simplify the 2. And then the x divides the x and 8x, but the x does not divide the y, so this is my simplified version. Number 5 is an interesting one. It looks like it's going to do just the same kind of things as the other ones. We have a denominator that matches, so I have z squared plus 7z plus 12. And in my numerator, I have z plus 3. Now, this one differs from the other ones because as we look to see if it actually starts reducing, we have to recognize that this denominator isn't in factored form. So I need to get it in factored form to see if, in fact, it might simplify with the z plus 3 on top. So as I look at z squared minus 7z plus 12, I have a z in both places, of course. It's all addition, right? So I have two addition signs. And then the number 12 can be broken down into 4 and 3. So 4 times 3 is 12, and 4 plus 3 is the 7 that's in the middle. And then we do recognize, in fact, that I have a pair that cancel. Now, when I cancel a numerator out, remember, canceling like this is division. So division of z plus 3 would leave me with 1, right? Take a number and divide it by itself, it's 1. So my numerator is 1, and my denominator is z plus 4. So this one actually simplified, whereas most of the other ones we've seen have not had any ability to do that. All right, I think the next one is our first one. Yep, the first one that we have that does not have the same denominators. So take a look at this one. I have 3a in one of my denominators, and I have just 3 in the other denominator. And just like when I was working with numbers, I need them to match. So if I multiply the top and the bottom by a, then they will both say 3a, right? So the first numerator is 7. And the second numerator is now negative 2 times a for a negative 2a. And again, the 3 in the denominator will not simplify with 7 and 2. The a will simplify with one of the a's, but the 7 doesn't have an a, so I don't have anything that will reduce. Oh, okay, number 7 has pieces of it that match, right? Just like on number 6, the 3's matched. On number 7, the x's match. But the numbers don't, and 7 and 6 don't have anything in common. So we would multiply the second fraction by 7 over 7, and the first fraction by 6 over 6, right? That will give me a 7, 6, and x in the denominator. So I have 6 times 7 and times x in the denominator. And then in my numerator, I'm going to multiply these out. So I've got 6 times negative 5. That would be negative 30. And then I have 1 times 7, which would be 7, and it's addition, right? So I have plus 7, like this. And yeah, I know that the denominator is a 42, but I thought it might be easier for the moment just leave it factored, and we'll multiply it out if we need to. This numerator is a negative 23. And the reality is that negative 23 is prime, so I won't actually be able to simplify it with the 6 or the 7 down here. So I'm going to go ahead and multiply those out. That would be 42x. So we wouldn't really need to leave it in factored form. It doesn't make any sense to do so on that one. Okay, let's make it just a little bit harder and do a couple more. On this one, you'll notice the denominators are very similar. One's an 8d and the other's a 4d. So the d's match, that's good. 8 and 4 don't quite match, but they are close to one another in the sense that 4 is a factor of 8. Which makes it really nice because I can multiply the second fraction then by 2 over 2, and then the denominator would in fact be 8d. So I have 8d for my denominator, and then my numerator I have 9d minus 1 for the first fraction. And then the second fraction's numerator I have to multiply through by 2. So I have 2d times 2, so that's 4d. Yeah, not 40, 4d. And then I have negative 3 times 2, which is negative 6. So it looks something like this. All right, so then I have combined like terms. So I have a 40 and a 90, going to be 13d. And then we have the negative 1 and the negative 6, which will give me negative 7. And I've got that denominator still present, which is an 8d. And again, on this one, nothing simplifies. On some of you have, there will be pieces that simplify, and on some there will not. Let's take a look at this one. This is a pretty good example of one where, yes, the denominators both have an x in them, but again, the x is a part of a term, it's not a factor. So the only way to get these denominators to have the same denominator, right, these two fractions to have the same denominator, is to multiply the denominators by each other. So the LCD here would actually be x times x plus 1. So on the, oops, I wrote minuses over there, my bad, make those pluses. Okay, so the denominator will be x times x plus 1. The first numerator has to be distributed out, so I have, this is terrible penmanship, but that's supposed to say x plus 1 and 7. It has to be distributed, so I have 7x plus 7. And then on the other one, I have 6 times x, and it's subtraction right here. You see in the middle right there, the subtraction. So I have minus 6x. And then if I combine like terms, the 7x and the 6x combine to give me x. I still have a plus 7 on top. And then in my denominator, I have x times x plus 1. You can leave it factored. In fact, I would prefer that you did. Some of your directions may even tell you to. Factored form, so much easier to work with, so we're going to leave it just like that. Also because as we take a look, we can see at a ready glance that the x plus 7 in the top doesn't have the ability to cancel with anything in the denominator, right? They don't have matching factors, and so we are done.